So one of the strongest bonds that we see in nature when it's released is a carbon-hydrogen bond. And so when these hydrogen are released, it's actually a carbon-hydrogen bond being broken, so a lot of energy is released right here.
Right where, sorry?
Right here, when it gives up its hydrogens. And so just remember, carbon-hydrogen bond's strong, and it happens pretty frequently throughout these processes, which is one reason why the body produces heat when you're exercising.
Okay.
So.
Awesome.
Cool. Okay. So question, what is involved in the trap?
In the trap, that's when glucose enters into the cytoplasm and ATP is added, right? No, not ATP, just kidding. ATP turns into ADP, adding phosphorate or something like that.
Yeah, a phosphate, right?
A phosphate, that's
it
what it is.
phosphoryzes the glucose?
Yes.
What's the first or the second decision that occurs?
The second decision?
Or first decision.
First decision. Does that have to do with like the enzyme splitting it up?
It has to do with what we're gonna do with this molecule.
Okay. First decision.
Depending on ATP, remember?
Oh yeah. Okay. What is the first decision? Whether like glycogen goes through or not. Something like
Yeah.
that?
So it's whether this glucose molecule is gonna go back to glycogen in the liver, or if it's gonna continue on with the process.
Okay, so glycogen and liver or continue.
Yep.
Okay, awesome.
Step number 3.
Fructose.
Fructose. How do we make fructose?
So, this is about the enzyme splitting it up, right?
Not yet.
No, it's not. That's
That's
number
the
4.
divide. Yep.
Okay. I forget this one.
Fructose is when the other ATP comes along, gives up its phosphate, and becomes ADP.
ADP.
So when you have the 2 phosphates attached to the 6-carbon glucose, that makes fructose.
6 carbons. Okay.
Yeah, so this right here is fructose.
That's fructose. Okay.
Does that make sense?
Yes, that does. So that's number 3.
Okay, now the part you've been waiting for.
Yes, the enzyme breaking it up.
Yes, breaks up the long poop, right? So breaks it up, now you have your 2 separate molecules, and what happens here?
The 2 separate molecules, well, there's a hydrogen on the molecules, and the phosphate. I keep wanting to say like phosphorate, but that's not a word. The phosphate wants to attach, but it can't. So the NAD plus takes it off and turns into NADH.
Yep.
Making a phosphate able to attach.
Yes, and so how many hydrogens are released from there?
1,
2 hydrogens.
2 hydrogens, okay.
And what's received by NADH?
Oh, electron and a proton. 2 electrons, 1 proton? Is
Yes.
that right?
Yep.
Okay.
You got it.
Okay.
All right. Any questions here at this point?
I feel like I'm bad at the first part.
Okay. You want to go over that one more time?
Yes.
Okay. Walk me through it.
Glucose enters the cytoplasm. And decision time, whether the glucose turns into glycogen, right? And goes to the liver.
So it gets trapped first.
It gets trapped, that's right, by adding the phosphate.
Yes.
Okay, cool. Then it decides if it goes to the liver by turning into glucose or continues on as glycogen.
If it goes to the liver as glycogen, it becomes glycogen, right?
Or just continues
Or
on.
just continues on.
Awesome.
If it goes to the liver, it'll become glycogen. For the
Okay.
most part, for the scenario at least. Yeah.
That makes sense. Perfect. And then that long strand is fructose. And the ATP turned into ADP, so they take away a phosphate.
They gave it a phosphate.
They gave it a phosphate. That doesn't.
Right? So
Oh, because it's ATP.
we were originally like
triphosphate,
this.
Diphosphate.
As a glucose,
Yes.
ATP comes along, becomes ADP, so it gave it a phosphate.
Okay. So
This one also gives it a phosphate,
Okay.
which gives us the fructose.
Very good. And then the split, and then I think I get that part.
Okay. And then let's go to number 5, which is,
Let's do it. Substrate level phosphorylation.
you just say that around people, they're like, dang, she's
I
smart.
was like, dang, that's pretty sweet.
Oh, it sounds like you're going through substrate level phosphorylation.
Just throw that in there sometime. So substrate level phosphorylation is this part.
Yes.
Yes, it is. And it's when you need to remove the phosphate. So it's ADP and it turns, to ATP, so it takes the phosphate.
Mm-hmm.
That's adenosine diphosphate and triphosphate. And then as it's taking, why does it need to take a phosphate away?
We're trying to produce pyruvate, and we're also trying to produce ATP. So if we didn't give away the phosphate, ADP would still be ADP.
Oh,
But we want
bad.
ATP because ATP holds energy.
It's way better, huh?
Yep.
Okay. So it's turning into ATP and taking away the phosphate, and then you're left with 3 carbon, and then that's pyruvate. Then NADH swoops down, adds a little hydrogen, goes back up. What does it do when it goes back up? Just stays there?
Takes another hydrogen from the next one coming through.
So it's just a continuation.
Yeah,
Okay.
so it's just a cycle.
Awesome. And then, so 3 carbon plus a hydrogen, that's lactic acid, right?
Yep, it's lactic acid.
And that's anaerobic.
Yes.
Okay.
So you produce a lot of lactic acid when you are doing anaerobic stuff, when oxygen is not available.
Awesome.
Okay.
Very good.
All right. Any questions here?
I think this is good.
Think you got it?
Yeah.
Okay. Is there anything else I wanted to bring up? I think that's
The
about
test
it.
asks a lot of like, if you are an alligator and you eat a saltine, what happens? So I don't even get like how to solve those kind of things. They're confusing to
Okay.
me.
We'll go over some practice questions today.
Awesome.
Okay. What time is it? 2:11. When did we start? 1:45?
Yes.
Okay.
I think so.
Am I good at races?
Go for it.
Okay. Remember that we made that pyruvate, right?
Yes.
So
we
we're
made
gonna
2
be-
pyruvates.
We're on decision number 2 right now. And we're going to talk about maybe a different scenario where a different decision is made rather than producing lactic acid.
Okay.
So we've got our pyruvate. And if we're drawing out the cell, we have mitochondria throughout it. We're going into the middle of the mitochondria where it's kind of like this. We're just going to go inside here.
Okay, cool.
That's where it's taking place. And it's called the matrix of the mitochondria, or the inner membrane. Wait, do they call it the inner membrane? They might call it the inner membrane.
I think they do.
Is it?
I think so.
Yeah, I don't know. I'll just wait. Well, I know for sure it's the matrix of mitochondria, though.
Okay.
Yeah. So decision number 2. Let's say there's oxygen available. We do need ATP. Maybe we're running something long distance where we do need it's not so explosive, it's not so intense. And we want to produce ATP. So here we are. This is our membrane wall. That's the intermembrane.
Isn't there a bridge thing that's coming up here pretty soon?
Probably. Oh, they call it, there's a name for it. It's
Yeah,
called-
Brother Grossbeck calls it the bridge. But
Yeah.
I don't really understand. Okay.
Just where it crosses, right? So
Yes.
once it crosses the bridge,
Mm-hmm.
so we just made our decision, right?
Made
It
it.
crosses the bridge. Right as it crosses, it's going to give up a bunch of stuff. So first thing it gives up is a carbon and 2 oxygen. What does that look like? CO2, right?
Oh yeah.
So if we just give up an oxygen, or a carbon, sorry, how many carbons are we left with?
2.
2. And so these 2, as they continue on, they'll make what we know is acetyl.
Oh, this is making
Sound
sense.
familiar?
Okay, yes,
Okay.
it does.
But before that happens, or as that's happening, we're also giving away 2 more hydrogen. You You remember last time we gave away 2 hydrogen?
Yes, I do, I think.
Who did we give it to?
We gave 2 hydrogen to, I'm not gonna look.
It's a taxicab for
Oh,
electrons.
NAD.
NAD.
Plus.
Yep. So NAD plus takes 2 electrons, 1 proton, and becomes NADH.
So it takes 2 electrons and 1 proton, always.
Yep.
Okay. And then it turns into NADH.
So we've got another
Wait,
taxicab.
how did it
over.
turn into NADH?
Oh. It gave away 2 hydrogens
Makes sense.
to
Okay.
NAD.